Is the clicker ready to use? Perfect. Okay, so next speaker is me. My name is Mark Michelson, and my presentation is called Composable Services in OVN. So first of all, let's just look at what we're going to be talking about today. So the first thing I'm going to do is I'm going to give a brief overview about the different types of data paths that exist in OVN. We're going to talk about what problems they introduced, and then we're going to talk about my proposed solution for these problems, which is OVN services. We're going to talk about the pros and cons of services, and then finally talk about future plans and possibly future services in later releases. Oh, optional subhead showed up. That's fantastic. Anyways, so I figure most of you are probably pretty familiar with OVN data paths, but I did want to go over this just in case, especially because the word data path is kind of overloaded in our world. In this case, what an OVN data path is essentially an abstraction of a piece of network hardware. So there's two types of data paths. One is the logical switch, which does layer 2 switching between VMs or other devices within a subnet. And then logical routers provide layer 3 networking between networks. That's all they do, right? Here's a little diagram showing about how these might be connected together, kind of typically. You might have yourselves a little, switch for different subnets connected to a cluster router. You have a gateway router that then connects to the internet. The problem is these data paths actually do quite a lot more than what they say on the tin. So logical switches, they have port security. You can program ACLs. They provide responses for DHCP requests. They can do limited DNS resolution as well. And oddly enough, you can do layer 3 load balancing within a logical switch. And then our QoS options pertain to logical switches as well. And logical routers, they're not quite as complex, but they do more than what they say. So for instance, they provide network address translation. They also can do layer 3 load balancing, interestingly enough. And you also have router policies. So what problems do we have here? So first of all, there's the problem of user obscurity. Brief survey here. How many of you have ever looked at the OVN North D man page? Okay, brief scattering of hands. Now, keep your hands up for right now, because I'm going to ask a follow-up question, which is, how many of you find that man page easy to read? Okay, I actually am surprised that there aren't 0 hands up right now. Okay, because personally, I find that man page to be pretty inscrutable. But the thing is, the result of this is that a lot of users see these data paths as kind of a black box. In other words, you're setting up a logical switch, you're setting up a logical router. I know I'm adding NAT to it. I know I'm adding ACLs, but you may not necessarily be aware of the order in which those get evaluated. You can look at the man page and look it up. But again, like I said, it's not exactly an easy read. But sometimes you can end up having this abstraction leak a little bit. So even though you think you're just putting some ACLs on your switch, you may realize that, wait a second, my ACLs aren't doing what I expect because they're being evaluated before the load balancing happens. And I want ACLs to actually operate after. And so in order to make that happen, we had to kind of, like I said, make the abstraction leak a little bit by adding a flag for ACLs to say, I'd like to have these evaluate after the load balancer, please. Also, because of this, you end up with these oddball options and knobs in the routers and switches that tweak behavior just slightly, and they may be a little bit hard to understand unless you were directly involved with why that option came to be in the first place. We also have a problem with rigidity. So in other words, these logical switches and logical routers, they have a bunch of stages in the pipelines. And if you try to mess with them, you might find yourself causing problems. So for one thing, we use OpenFlow registers to indicate a lot of options, to indicate a lot of other things within those data paths. And I'm not going to say we're running out of bits necessarily, but space is a little tight, especially in logical routers, because we use 8 registers just for the previous hop and next hop IP addresses. And so for trying to store other information, you know, we can't be using a ton of them. And honestly, we're starting to see the same thing with contract, because contract has the 32-bit mark and the, what is it, 128-bit label that we keep putting stuff in there. And, you know, we could be finding ourselves running out of bits at some point. We also do this thing pretty frequently where we will jump to a later table outside of the range of OVN's natural boundaries. So we'll jump to table 90 to do something like looking up a MAC binding or something like that, and then jumping back to where we were before to continue processing. You also can end up seeing some unexpected behavior here. So a good example of this is if you have a stateful ACL configured on a logical switch, then all traffic that goes to that switch is going to be committed to contract. And the reason for that is because OVN North E doesn't know the details of the ACL, and it can't reasonably parse it and try to know, well, only traffic from this particular VM is relevant to this ACL, so we'll only commit traffic that involves that particular VM. So we have to do everything in order to be able to properly recognize that, say, a reply packet that initially had nothing to do with an ACL actually now matches. And this is a bit of a contrived thing, but I did say that you might write yourself into a hole by writing an ACL that blocks intended traffic like DHCP or DNS. And look, I'm a developer. I'm going to be a bit selfish here. We find ourselves having headaches with this. So we can find ourselves accidentally introducing, I won't say bugs, but complex behavior with logical routers is a good example. So if a packet has been natted and then we need to program some sort of response, we might have to know, oh, actually put the natted address into the response so that it gets unnatted properly, rather than just always using the router's interface network address. Also, the big thing we've been trying to do a lot is to incrementally process database changes in OVN. And when the databases, when the data paths are so complex as they are now, we find it to be a major headache to actually be able to do the incremental processing properly. I know that there have been a couple of tasks on our queue for ages because it's just such a headache to try to get those done. And if we do get them done, yes, it'll probably make the code faster, but trying to actually understand what's going on is going to be difficult. So this is a possible solution to this problem, and it is composable services. So going back to our original slide, what are the data paths in OVN? The proposal is we will have a logical switch, logical router, and services. Yes, logical services. I like that. So what are services? So remember when I listed all those other things that logical switches and logical routers do other than switching and routing? Well, the idea is that we might be able to extract that behavior into an independent data path, and that way they're not under the command of the switches or routers anymore. They are their own thing. The first candidates for this are NAT, load balancer, and ACL. So here's an example. So in this case, we have a gateway router connected to an external switch, which goes out to the internet. Now, normally, You might have ACLs in this external switch. You might have a NAT in this gateway router, but we've extracted those into their own independent data paths. And interestingly, we've actually reversed the order. We actually have the NAT happening here and then the ACL happening, because if you compose the services yourself, you can do it that way. Similarly, we have another example here where we have a couple of VMs attached to a switch, and we know that this ACL only applies to VM1 really, so we've put the service here between VM1 and the switch, and meanwhile, we know that we're going to be natting everything that comes out of VM2, so why not go ahead and put a NAT right here before it even hits the switch? Normally, you would not be able to do this at all because you'd have to hit a logical router first before NAT could happen. So, how do the services work? In a nutshell, they are data paths in the sense of OVN. So in other words, they're going to program their own logical flows. They're going to have their own independent register space for OpenFlow. The services, the way that I've proposed it here is each service is going to be linked together in a linear chain. So there's not going to be any sort of branching or anything like that. And then the service chain gets attached to what I've called here a pinned logical port. When I say pinned, what I mean is a logical port that is bound to a particular chassis. So in this particular case, we're talking about gateway router ports. We're talking about switch ports to which VMs or pods are attached. And the way, and since it is a chain, I'll go back a slide here. The idea is that the chain runs in one direction on ingress and one direction on egress. So packets coming this way would first get natted, then they'd go through the ACL, and then reply packets would go through the ACL first, then get natted, and then go out. So under the hood, let's talk about the components of OVN and how they actually affect things. So in NorthD, services are essentially translated into southbound data path bindings. And then there's 2 port bindings created for each service, and those are just used to link the service into the other parts. So using this as an example here, this would be one of the logic port bindings here on the ACL, and this would be the other port binding down here. And OVN controller honestly doesn't have to do much different than what it does now. OVN controller is already very good about sending packets between data paths. So OVN controller would see these new data paths and port bindings and just write the physical flows to actually send the packets between the logical data paths. And they would just have to be aware that they only need to program the OpenFlow for local services. In other words, services that are bound on that particular chassis. I didn't want to get too into the weeds in configuration here, but one of the big things, especially for these first 3 services that I've proposed, is we're going to just reuse the existing OVN NorthD tables. So the ACL table, the NAT table, and the load balancer table. But then we're going to have kind of a wrapper table for each of those, which is the service table. So in other words, we'd have an ACL service table, a load balancer service table, et cetera. And those would be used to group ACLs, load balancers, et cetera, into one service. Then there's a service chain table, which will define the linear chain of services that you want to use. And then finally, the logical router port and logical switch port will have a service chain column to which you can put a service chain. So let's talk about pros and cons of services. First of all, remember there was the problem with user visibility. If users are configuring a service chain themselves and they're putting the services in the order that they want them to be, it's going to be a lot more obvious to them what happens when. And I also, again, throwing shade at the man page saying you don't have to look it up in order to know what's going to happen because, again, you've defined it yourself. Data path simplification is a big thing. If logical routers and logical switches can focus on their core duties rather than additional functions, it's going to make it so that it's a lot easier to understand what's going on with those. Also, I've invoked the Unix philosophy here because the idea is if you have services that do one thing and do it well, again, it makes things more simple to understand. Contract. Remember, I talked about how with ACLs, stateful ACLs on a logical switch, you might find yourself saying, every packet is going to contract. Well, if you instead are putting those ACLs only on relevant ports, then you may not see that happen anymore. So I've even drawn ourselves a little example here. So this is current OVN. So in this case, we have a logical switch with a stateful ACL. And we'll just say hypothetically that VM1 is the only actual VM that will match this ACL. The problem is that VM2's traffic and VM3's traffic are going to get committed to contract as well. But with services, what you can possibly do is you define an ACL service between VM1 and the switch, and now only VM1's traffic is going to get committed to contract by this ACL service. Meanwhile, VM2 and VM3 aren't hitting any sort of stateful ACLs, and they're not having their traffic committed to contract. And of course, development. If services are only doing a small amount and don't have a ton of options associated with them, it makes it possible to write incremental processing code that can possibly be done quite a bit faster, more easily, more reliably. And the other thing that's interesting about services is that they're all a data path with 2 ports. There's a lot of overlap between them. So there's probably going to be some common code that can be used by all of them. So we're not having to custom tailor our code for each individual service. One thing that's also cool is every service is opt-in and it's an add-on to the code. So we're not modifying existing logical switches or logical routers, anything like that. So we're unlikely to cause problems for people who upgrade to a version of OVN that includes services. Now we have the cons. And I'm kind of bamboozling you a little bit because I put all the cons on one slide to make it seem like there are fewer of them. But one thing, of course, is even though you introduced this great new idea that may be a bit self-aggrandizing, but we can't just get rid of the original way of doing things in OVN. Because we can't break user setups. So presumably, at least for a while, we're going to have to support both the services version of things as well as the old integrated within the logical switch and router way of things. Now, I didn't put this in writing on here, and I did this on purpose, but I'm going to tell you guys something. It may also be possible that, at least for logical routers anyway, we might be able to implement the configuration on logical routers as services within OVN North E, just do a little conversion, in which case then there would be a single code path for everything to a degree. I'm not guaranteeing you that. Maybe that I try to do that and it fails horribly. Another con, ACLs. Right now in logical switches, ACLs can match on things like the input port or the output port or a known register value within a switch. If ACLs are implemented as a service, they have no concept of switch ports, and they have their own independent register space. So it may be possible that the ACLs you want to write are not possible now. However, since ACLs are applied per port, it may be you could just apply the ACL to the relevant port anyway, and therefore you don't need to have the port match anymore. It's possible. Okay, so contract. I said earlier that we might have fewer contract zones, we might have fewer commits to contract, but it's also possible you could have more. If you just chain ACL, 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 NAT, ACL, ACL like that, then yeah, you could end up finding yourself actually using more contract than you expected, than you did before. But I mean, you kind of did that to yourself, I guess, by having that many things in the chain. I also mentioned the services only partially address the all traffic goes to contract problem. Again, that's the case of if you can't just offload the ACL to a specific port, then you still have to have the ACL on the switch, and you're going to have the same problem that you did before. Okay, so that's the initial plan for services. So let's talk future. External service. So the thing is, if you have yourself just a data path in a box, there's not a lot of limit to what you can do as long as you're just trying to do one thing and do it well. So one idea is an external service, which is basically packet enters service, packet gets sent out somewhere. In the initial idea that I had, the idea was to just attach a port to an OVS bridge. send the traffic out that port, and then when the traffic comes back in the port, send it back out the other side of the service. There is another proposal from Nutanix that had a kind of similar idea, but of course they weren't aware of services, so we're kind of trying to work through that. I'm probably going to be talking with them next week, week after, something like that, to try to make sure that we're on the same page and no one's stepping on anybody's feet there. The other thing about external service is we might eventually make it NSH aware. So the idea being, instead of just sending a packet out, we might be able to put some network service headers on it, send it out, and then be able to understand network service headers that come back. We might be able to service size more things. I wasn't sure about how to say that, so I just said it that way. The thing is, I don't want us to be in a position where we make everything a service, because then it might be cumbersome for users to configure everything that way. But everything that a switch can do right now could potentially be implemented as a service. So DHCP, DNS, QoS. And what's interesting is, if you think about the idea from the external service of the service could potentially send the packet out of OVN to do something, it means things like DNS, for instance. Right now we have kind of limited quad A, and maybe one other type of record lookup that we can do. But it may be that the DNS service could send traffic out to a DNS cache on the chassis to do some more powerful DNS lookup beyond what we already have. And then the final plan for the future is the idea of hook services. So as we saw in this document, these services stand alone as their own independent data paths. But there's some things that we might want to be able to do that actually affect a data path's operation. So this is where a hook service might come in. And the quintessential example I use is logical routers have this idea of logical router policies. And one of the actions you can do with a logical router policy right now is change what the next hop IP address is for the packet. Well, the next hop IP address is not actually part of the packet. That's just part of what the router knows to do with the packet. So you can't really just tell a router to do that by updating the packet itself. So instead, you'd have to have something call out from the logical router, and then that thing that it calls out to would then have to know to change a factor within the logical router itself to update the next hop IP address. This also is where potentially we fix the problem of ACLs being able to match on switch ports, et cetera, instead of them not being able to do it as standalone services. Oh, I said final before. I forgot about this one. I added this one late. So right now, in the proposal, services are a linear chain of data paths. And it may be worthwhile at some point to think about having them actually be able to branch. Again, the thought in my head here is, I don't want people to make these complex, horrible, monstrosities of a network. Instead, rather, it might be a case of you have one path that is the stateless path and one path that is the stateful path, again, to avoid contract where it's not necessary. The problem is, I absolutely have no idea how you'd actually implement this, because I would think you'd have to use contract in order to know how to traverse the backwards path after it's branched. So anyway, it's just a thought in my head, might not ever happen. Okay, well, thanks everybody. I enjoyed presenting. Does anyone have any questions?
Thank you, Mark. So are you going to keep the old way of doing things and also new way of doing things forever? Because like with a new way of doing things, if I have to add an ACL, now I have to create an ACL and add that ACL to a ACL service, then add the ACL service to a service chain, and then finally put the service chain on the LSP. So there are like 3 prerequisites and then add it to the LSP, right? And then today we just add one command and everything kind of aligns.
I can't speak for the foreverness of it, but like I mentioned in the presentation, we will have to, at least for a while, I mean, I would say probably for at least 2 LTSs, support both ways of doing things, because again, we don't want users to rebel against us. Václav.
Thank you, Mark. I have a question. Do I understand correctly that with an external service, it would be possible to output packet from OVN pipeline processing to some physical device for stateful for packet deep inspection and so on, and then turn this packet back to OVN processing.
Yes, absolutely. The whole thing from OVN's perspective, at least as I've proposed it, is OVN sends the packet out to an OVS bridge. At that point, we don't care what that OVS bridge does. It could send it to some external device. It could just write its own flows at that point. But then we do expect the packet to come back. If it doesn't, then we just assume it was dropped. But if it comes back, then we forward it on through the rest of the service chain. Any other questions? Jacob.
Are the service chains symmetric, or can ingress and egress behavior be different?
So I want to make sure I understand the question first. So one of the big things, and this is one of those where I didn't want to get into the weeds of configuration, but one of the things that's going to be configurable both on the service chain itself as well as each individual service is a direction indicator. So for instance, NAT, let's say NAT. Do you want a DNAT to DNAT the packets that are ingressing into the port that it's attached to, or do you want it to DNAT packets that are egressing from the port that it's attached to? So you'll put that so you can indicate which behavior you want. But other than that, that's the only sort of thought I've given to opposite behavior on ingress or egress. Felix.
Thanks a lot. Would this require change on OBS, as it seems like this would cause a lot of more recursions and we would be a lot easier to hit a recursion limit?
That's a good question. Recursion isn't the one I was thinking about so much as the resubmits. But yeah, I guess we would be probably cloning packets between the data paths, so between the services rather. So it would potentially result in more clones than we normally see. I think what's the max depth on that? 16, is that right? Or is it more than that? For nested. Okay. So we might have to have some sort of limit implied within OVN, or maybe not. I don't know yet. What's that? Oh yeah, okay. So Girish suggested using the deferred thing that Ilya was talking about. Do we have any other questions? Sorry, we have competing things. Who first? Oh, Ilya has a comment.
Yeah, just if we construct our pipelines in a way that you presented, where our services are chained with like a single line, like assuming without branching, without this last idea, then we don't really have to clone the packet, because packet goes one way and when it jumps to the next data path, there is no actual clone because there is only one copy of this packet. So it may be optimized by OVS by default, so we may avoid some of the extra branching or extra resubmitting and whatever. So OpenFlow processing may be more optimized in this way.
Okay, thanks for that, Ilya. Vladislav?
A small addition here. Each service could be a separate OVS bridge, and using Apache ports, you can pass traffic for processing to this bridge and return it back. I know some cloud, which is written by their own OpenFlow controller, they do this stuff.
Okay, so that's an interesting suggestion. The one thing with that is we would have to change how OVN controller interprets changing data paths in that way. So, I mean, I don't want to say, oh, that's more work, so I don't want to do it, but that's initially my reaction. But it may be that we have to do that if we start running into limitations from typical setups, say with OVN Kubernetes or with other common setups. Alish, hold on a second.
Yeah, just one small comment to the addition to the limits. I think we might be hitting resubmit limits and the recirculation limits with that, because nowadays the pipeline is kind of predictable in a way, because we know how many stages we have there. So we know how many resubmits will be there, more or less. With the services, we don't know at all. And the same goes for the contract, because we need to do recirculation for every single contract. So it might impose some hard limits how many services we can chain together. But yeah.
Well, so Ilya just said that's not our problem, that's the user's problem, but it may become our problem. So, okay. So I am out of time. Thanks everyone for the questions. And I guess please clap. And